Hi, I'm Atri Indiresan from Cisco Systems, and this is work I did with my colleagues Mel Sai and Manas Pati, who's in the audience over here. So just a very quick history. So till maybe about a year ago, we were, as Josh and Stephen will tell you, we were actively resisting the urge to do OpenFlow, and then we got religion, and here we are. So we wrote our first line of code around last December, and we participated in the Plug Fest in March, which went pretty well. So we've made some progress, but how we got here was an interesting experience, and I'd like to share some of that. So I'm just going to talk a bit about Faucet versus OpenFlow. I think there's a good consensus over here, but I really want to focus this talk on what it takes to effectively implement a pipeline like Faucet in hardware in an efficient manner. So first, let's just say Faucet versus OpenFlow. I think for this audience, this is not controversial. So Faucet is a practical subset of OpenFlow, and I say this as a very positive thing. OpenFlow is many things to many people. It is incredibly flexible. I do believe it is more a software paradigm than a hardware paradigm, but what was done in Faucet really helped us define an efficient way of doing something useful. And to be honest, I'd say efforts like this or maybe other profiles are what could make OpenFlow effective. So let's dive straight into the pipeline. So first of all, let's look at a functional model, then we look at the implementation model. So what do we want to do? So baseline functions, Chris has been talking about these, which is a great lead-in talk. So we want to do L2, L3 forwarding. We want pretty good statistics. There's certain additional functions which are still pretty core. You want ACLs. You want to handle some protocols, maybe not all. You always need to punt to controller or someone with more intelligence. Monitoring, you can mirror the traffic, etc. Maybe in the future you want to do meters and more tunnels. I know tunnels are not popular, but and they feel it's not necessary in this paradigm, but you never know. Okay, so you've all seen this kind of figure in multiple different places, and the diagram which Chris put up and which is on the Faucet website, it looks very similar. So now, again, this is an abstract model. What does it look like in reality? And when you look at the match action stage, they really mean a flexible match action stage. But the devil's in the details, right? So you come in, you parse the packet, and you do some intelligent stuff along the way, one after the other, and finally you go out. But it really doesn't say in your match action stage, what do you match against? Where are the tables? Are the tables tied directly to a particular stage, or is there some kind of a crossbar over there that you can access any memory from any stage? And these are very important design decisions when you're actually building an ASIC, because they might increase flexibility, reduce cost, whatever. There are different points in your decision. So let's look at, I think I spoke to this. The only other additional point I'd like to add is the rewriter. Do you want to modify the packet as you go through each flexible stage, or you want to do it at the end? So the logical abstraction in OpenFlow is that the rewrite happens immediately. But most hardware I have seen, they gather the rewrites, and then you have some kind of a rewrite engine at the end of the pipeline and make it happen. So, different ASICs do things different ways, but again, this is an implementation decision. But the logical abstraction over here is when you modify the packet in OpenFlow, it happens immediately, and that result is visible in the later pipeline stage. Transmitting, nothing much going on. You always have to send packets out. Okay, so let's look at the hardware resources. You want a programmable, flexible parser. Right now, it's just IPv4, IPv6, Ethernet, some layer 4 fields. Maybe in the future you want something more. But once you've programmed your parser, I mean, you're done. You really don't need to mess with it too much. Maybe you want to. So it's good to have it programmable, but I don't want to spend too much time on it. The action really is in the middle part. So let me deal with the rewriter. So I think there is a value in being able to rewrite packets on the fly, especially if you want some more complex function, like I want to mirror a packet in the middle of the pipeline. So what am I going to mirror? The packet which came in, the packet which is going out, or what the packet looks like at that point of time. And this is a really, really hard problem to solve. And I think the way it's been solved in Faucet is, oh, we're going to mirror packets in the very first stage before any changes happen, so you've got the original packet. But in my conversations with Josh, he said, well, it could happen somewhere else. I hope not. I mean, we could figure it out, but it's hard. So just to make a point. But it's really the match action stages where all the action is. So I'm going to focus a lot more on the matching rather than the actions, but we can talk about that in the future as well. So we have different kinds of lookup tables. You can have TCAMs. You could have a special longest prefix match kind of hardware, hashes. These are really the common ones. You could have some simple tables, but the difference in cost between a hash and a regular linear table is not a whole lot. So
sorry, maybe
sure.
as a term of art, so the mirror in most of the industry, the mirror is quite a well understood term.
Sure.
But I guess another way to think of it is just a multiple output, because there may be, if you want to put some metadata on that packet for an external NFV application to know about.
Correct.
Yeah. So the mirror is the special case of data. You didn't put any data on it. It's really, occasionally you may want to do multiple output.
Okay, fair enough. And you just made the problem a little harder.
Yes. He's very good at that.
I know. Okay, so some rules. I had interesting conversations with Josh, and he sincerely felt that, okay, we tell you to do something and it should work magically without performance impact, and no, just do what we tell you. And he's very persuasive. And so we came up with an initial design which was fairly performance impacting, and he emphasized the importance of doing it better, and we went back to the drawing board. We came up with a better design, so thank you, Josh. But having said that, here are the rules. Hardware resources are scarce, and flexibility can be expensive. So the more flexible you want to be, you have to pay a price somewhere. Hardware is definitely more rigid than software. If I want to redefine my pipeline and software, just put a new data structure and stick a new function over there, and magic, it just works. You've written the code in half an hour or a couple of hours or whatever it takes, and you define a new pipeline. Over here, somewhat more. TCAMs are our most flexible matching hardware, and they are significantly more expensive than hash. It's not even close in terms of scale and cost, real estate and the ASIC, everything. So if you don't use your resources efficiently and effectively, it could come down to even impacting functionality. There's certain things you just can't do because you've consumed too many resources doing something else. Obviously, you can impact performance if you spend too much time in hardware doing things in a complicated way, and scale as well. You, again, use too many resources, nothing's left for the other stuff. So we need to be respectful of this when we are designing a pipeline. These decisions are relatively easy when you have a fixed function pipeline. Say, oh, I need to do this over here. By the way, that match action stage pipeline I defined is exactly what a traditional pipeline looks like in an ASIC 10 years ago, except that they weren't very flexible. Today, we build them a lot more flexibly. But in a non-flexible one, you can put resources exactly where you want them. Oh, I want to put an L2 table over here, and an L3 table over here, and an ACL table. And it's completely fixed function. And you can make it happen very efficiently, but in a very rigid manner. So now let's look at what's in Faucet. And I want to state up front, someone who works on the hardware side of these things, is we do have a problem. We have solutions, But there's a problem, and I think maybe there are better solutions. That's what I really want to talk about. Okay, so right now Faucet has 9 or 8, which depending which way you look at it, the V4, V6 fib are in parallel, and it's really an open question. Do we need more? Can we do with fewer? Are these stages a partial order or a total order? Now, this is a very, very important question because already we see that there isn't a total order. V4 and V6 are in parallel. Is it possible to take some of the other stages and break them up into multiple logical stages? And maybe the hardware has the capability, maybe it doesn't. And you can do certain things, like kind of a demux logic over there, and you can create different keys and do different things in parallel, or maybe actually you just select one path and do that. And that might be a more effective way of designing your pipeline. And the device driver looks at the logical model and says, oh, this is how I map it onto the hardware that I have. The other thing is recirculation is expensive. So every time you recirculate a packet through your pipeline, you are giving up pretty much that full bandwidth, right? So let's say you could do something in one pass, you take 2 passes, then your packet forwarding rate drops 50%. Your line rate might not drop, it's just that now instead of doing line rate at 100 byte packets, now you're doing it at 200 bytes or whatever, which is not terrible. Our average packet size is probably closer to 500 bytes or more. So, but if you can avoid recirculation, I would say that's a good idea too. Okay, so let's dive in. And I'd like to talk a bit about how we actually went about designing our pipeline for Faucet. So I asked Josh, okay, so what do we have to do? Oh, look at the web page. It's all over there, cyber RFP, whatever. So yes. And so we ran the simulation on Mininet, and we generated the logs of all the flows. And I wrote a few simple scripts, and it extracted every match action combination that was there in each table. So if you look at 1.3.2, this is what it looked like for the fib table. In the beginning, we had an entry over there which looked at an ICMP packet and VLAN network source, network dest. Does that really belong in a fib table? We didn't talk about it, but clearly they thought so too, and they moved it to the VIP table. And right now, in 167, it looks really clean. You're just looking at the VLAN and the destination. The one on top is really it's your catch-all entry. So that's fine. That's like a /0 address. So we are good. EtherDest, on the other hand, got a little bit worse, right? So it used to be very clean, VLAN and destination, and now suddenly you put in an import. So basically, I think this is what Chris was talking about a moment ago, that you need to be able to send the packet back out where it came from, because I looked at all the rules which did that, and they all did that. Come in on import, and your destination was import. So you're trying to force the packet back from where it came. So maybe it belongs in a different table if we can manage, just because I don't want to make, let's say, the more important tables complicated. So when I say they become complicated, here's the implication. If I have a very simple table with a fixed key, fixed width key, no mask, nothing, it's very easy to implement with a hash table. If I put in more variants of the key, I have to start looking at TCAN. And like I said in the beginning, TCAN's expensive. It doesn't scale very well. On our ASIC right now, we have implemented Faucet using only TCANs. And it's a frightful waste of resource. We have lots of hash tables in our ASIC, and if we can figure out a way of doing things efficiently, scale will improve just with some software changes. So that's an opportunity. It's good for everyone. Okay. Okay. I cannot overemphasize this. I don't like this. Okay. Chris talked about it. There are other tables. Please put it in port ACL, VLAN ACL, something, right? So when you have a kitchen sink, don't spread the kitchen sink throughout the house. It belongs in the kitchen, in the bathroom, wherever, right? Not throughout the house. This entry in green is the only one. I mean, yesterday, I think in your talks, Steve, you talked about, okay, source is a tuple. Import, VLAN, and source. Keep it that way. So if you can have a clean table, guess what? This is a hash table. Today, it's a TCAM. So, you want maybe 1,000, 2,000 MAC addresses. We're good. We've got enough TCAM to do something like that. But, you turn around and say, oh, I want to support 10,000, 20,000, whatever MAC addresses, and you put the same number in the destination table and in the source table, and guess what? Suddenly, the system just doesn't scale. So if we can change how we do things, life will get better. Okay. Okay. So.
Do you want to take a question now?
Oh, absolutely. Anytime. Feel free. Oh, by the way, I'm deliberately being provocative, so feel free to shoot me down.
No, I don't want to shoot you down. I want to ask what you want.
Yeah.
So, sure, in some hypothetical other project that none of you have seen, I have a lot of tables, and we have a lot of these problems, I would say, in the tables. And as creator of the pipeline, from the top down, I recognize that I'm making a mess.
Yes.
Like, I get it.
Yeah.
What I want to do is I'm wondering, I don't want to give you the mess. I don't want to give the OpenFlow switch the mess. But if I'm going to give you really unravel it, I'm going to hand you 55 tables.
Yeah.
Because I want to take every one of those sections.
Yeah.
And I want to make them their own little tiny table.
Okay.
But of course, I realize none of the hardware I have available today is going to support 55 tables.
Sure.
They're all going to go and die. And there's blocking sizes, and it's just never going to work. So we have this bizarre tension. I want to give you guys the hardware everything you have so that you can arrange it as optimally as you can get. But then I need assurances from all you hardware folks that if I give you 55 tables, if you're going to implement it before, that you'll do that behind my back, and all will be happy.
Okay.
If I have to look at a table like this and say, I'm going to guess for this hardware that one in green is the important one, and I'll take 2 kitchen sinks and make them on either side of that, and have a now I'm guessing what the hardware is going to be good at. And I'm probably going to guess well for the switch that's sitting in front of me.
Okay.
I'm probably going to guess poorly for the switch that I'm going to buy in 6 months.
Okay.
So can you guys do that? Can you take 55 tiny tables, tiny specified tables, and say, yeah, I'm going to throw those 4 into one kitchen sink?
So maybe to paraphrase my friend and colleague, so we have our creative tension here.
Sure.
Right? So as you pointed out right at the beginning, it's like the ideal software world, which is ideal, and there's the ideal hardware world, which is also ideal.
Right.
We're just trying to discover where is the happy medium.
Sure. I mean, it is an interesting question, and let's put it this way: we have. I can't give away too much by way of trade secrets, but let's just say we have considerable amount of flexibility in our ASIC. So just to give you a little historical perspective, this ASIC first version was designed, 4 or 5 years ago. It was meant to do, a little bit of Ethernet switching, IP, some ACLs and stuff. And later someone said, guess what? We need GRE. We were able to do it. We need MPLS. MPLS was hard. We put an MPLS on the same ASIC. OpenFlow came along. This was not designed for OpenFlow, but we turned it around in a couple of months. VXLAN, we did VXLAN. So we have an ASIC which looks like fixed function. It's fairly flexible. I mean, people have seen what the barefoot architecture looks like. I'm not saying it's the same, but somewhere in that general vicinity. So if you give us a large number of tables, 55 seems a lot, but maybe, yeah, fair enough. But one of the things that we can do, remember I asked the question, is it a partial order or a total order? So if you can define these as a partial order and we have a clean demuxing function, at least on ours. So for example, in the fib table, I just check, is this packet V4 or V6? And so I'm going to form my key differently. Then I can actually decide which way the logic goes. It's an if selection. No, so it's not terribly hard. I'll reveal something. My boss is not here, but my job's not that hard, right? I've been developing software for so many years, and I can go months without writing a for loop, right? It's straight line code. You saw what that pipeline looked like. One after the next, and there's some selection logic in between. So I go somewhere, one to the next. So hardware forwarding of necessity needs to be simple, right? And that's the only way to make it really efficient. So if we can define partial orders such that you can just say that the longest path through this, and not just it's a partial order, that all of these stages are parallel and we have a clean way to distinguish the key. Okay, in the stage, if it's an ARC, I'll do this. If it's V4, if it is V6, maybe if it's ICMP, I can do different things. If I can make that decision in a very clean way, there is a good chance that I can separate them and form different keys and use different resources in the same stage, because I'm not doing all of them. Right now, I've decided to do all of them. I have a 512-bit wide TCAM, and I put every imaginable field, L2, L3, L4, your ports, whatever else you want over there, and it just magically works. It's a TCAM. Oh, I'm not matching on this. I mark that field. I don't care. Guess what? It's easy. It works, but it's not efficient. So that's why I said we can have this conversation, what kind of thing, and maybe you'll have a different conversation with a different vendor, because their hardware capabilities are different, and maybe they have a small number of processing stages, and you have to keep recirculating to achieve the kind of things that you're talking about. And maybe we have fewer or we have more, and we do things differently. So finally, you have to map it onto your ASIC, and this is also what Josh expressed to me. This is the functions that we have, and it doesn't really matter to us how you achieve it. That's the responsibility of the driver. But what I'm trying to say is, if you give us this kind of information, and maybe the driver can do something intelligent with it, and now I'll start writing slightly more complex code in my drivers. It's no longer straight line, simple graph traversal algorithms. I can still do these things. My brain's not yet fried.
By giving you this information,
yeah,
you mean table features, right?
It's table features, unfortunately, does not cleanly express concurrency.
I would like to discuss this with you offline in great detail.
We'd love that. So if there are enhancements to table features which express this concurrency in a nice way, it's something that we could use, which anyone could use. And maybe, maybe a future ASIC we need to design to use this information better. But right now, I think we are at a point where I can say that I have begun to understand what Faucet looks like and what the requirements are and how we can do a good job with it. And that's what I'm trying to express over here.
So, well, number one, thank you very much.
Sure.
For the work. And actually, this just as another observation. So there's different meanings of the word optimal.
Yes.
Right. So for us, the optimal flows are the ones that cause our business to work.
Yes.
And that may not be optimal in terms of, like, we may use more expensive hardware resources than possibly we could. But,
yeah.
But the boss is happy, so it's good. So that doesn't.
So before you finish that thought, I just want to point out,
Sure.
When I started, the first thing I said, what's the functional abstraction? And then I said, what's the implementation abstraction? So I fully agree with you. If the device doesn't do what you want it to do, it's worthless.
Right.
So please go ahead.
Well, but just so on that, I think in all the work that you've done, kind of this point is taken it to where we can really use it. So
Sure.
I really appreciate you engaging in this creative teaching, to get to this point, which is it's extremely helpful.
Thank you. Okay. So let me, go ahead.
So what I've inferred from the way you described this is that if a given pipeline stage, if a given OpenFlow table has one kind of match, you do it in a hash table. If it has more than one kind of match, it has to go to a TCAM. Is that assumption?
That's a hardware-specific decision, and it's not a question of one kind of match versus multiple. If it is a fixed match, then you can do it in a hash. The moment you put in a mask, it's really, really hard to do it with a hash table.
Okay.
It is still possible, but it is incredibly hard.
These are not so different from the performance constraints in software, in fact. And
True.
So you showed a table with 8 kinds of match. And so in software, we would implement that by having 8 hash tables.
Yes.
And just running through all of them and picking the one with the highest priority.
Correct.
And so I wonder if you have the facility, the ability to simply use multiple hash tables for a given OpenFlow table.
Yes and no. The problem is that we need to form the key. So if we have a selection logic ahead of doing the hash lookup, yes. But if it is hard to decide in advance how to form the key, then we really don't know what to look up. With a TCAM, life is so easy. You program the entry, and when I form the key, I just put everything in it. So if there is a selection logic for the keys, and if we have some way of expressing that, maybe as part of TFM or something else, then I would say it is easier. And again, like I said, I don't want to speak for all ASICs at all times, but what we have a certain degree of flexibility. And so the answer is yes, maybe. Okay.
All right, thank you.
So, yes.
Quick question. Are you having to develop your own silicon, or are the merchant silicon chips available good enough?
I don't believe there is much by way of merchant silicon which has this level of flexibility. I mean, clearly there's Barefoot out there. They're really new in the business. I've taken a look at some of their architecture. I think they have different kinds of constraints in the way they do things, but they seem to have done a pretty good job. I don't know enough about some of the more recent stuff which has come out of Broadcom. I do believe they're somewhat more constrained. The newer switching ASICs are more multi-function rather than flexible function. They put in a lot of functionality. Like I said, all the stuff I said we did in our ASIC and we just programmed it. Guess what? It's there in Broadcom, right? They have their VXLAN, they have MPLS, they have L2, L3, and the works. The difference is that we had a common reference architecture, and we were able to use software and drivers to make these things happen. So maybe if you squint hard enough, you could make some traditional pipeline work, but unless some flexibility has been built into it, it's hard. If you look at network processors, it's not a problem, right? It's obviously you can get the functionality because it's a CPU finally. Obviously, you have problems related to your scale and performance and so on, but you can do it in a network processor. But switching ASICs are significantly cheaper and more powerful as a rule than a network processor. So that's really where we want to go in the enterprise. I don't think people want to pay 5 times as much for an NPU-based system. Yes.
Yeah, I've got to respond to that because merchant silicon sitting out there, there's at least 3 chips that implement that pipeline unchanged.
Okay.
Fully featured.
Okay.
x86, we run it on that. Mellanox, we run it on that. We pass all the stuff. Barefoot, we run it on that at 6.5 terabits.
Sure.
Unchanged.
Sure. Barefoot is built this way. x86 is software, finally, right? So
Yeah, but I mean,
yeah,
it's
fair
a
enough.
platform.
Yeah.
If you're under 80 gig, it's the perfect platform.
Sure.
All of those have the same characteristics, that the mapping between OpenFlow and the specs and the pipeline that's implemented in the chip
Sure.
is very close.
Sure.
It's a one-to-one mapping.
Mhm.
And, yeah, 6 terabytes at Broadcom pricing
Yeah.
isn't a penalty.
No, it's great. And the point I'm making is we also have the one-to-one mapping. I'm just saying that we have to make certain compromises in terms of how we scale these things,
That part,
and we can make it better.
that part I absolutely agree with you. The OpenFlow pipeline designers
Mhm.
have got to understand an exact match versus a wildcard match, what the cost of those are.
Yes.
And code that into their tables.
Yes.
But beyond that, you can do a one-to-one mapping at very high functionality, very high flow table.
I agree.
Yeah.
I mean, if we can do it, like I said, there's no magic. If we can do it, someone else can do it too. So, just again, basic principles, what I've been talking about. If you can, fix keys for large scale tables. So the most obvious one are source and desk map. These are fixed lookups. And if there's some MAC address with the mask, you can create a small side table and do something with that. You really aren't doing source IP lookups. If you want to do URPF, RPF, things like that, maybe. Desk IP, if you have host routes, especially in an enterprise, you're going to have mostly host routes. You can put those in a hash table. Longest prefix match, you can put in TCAM or some kind of radix tree structure, whatever the hardware supports. And again, you can optimize over there. And again, you can make narrower keys rather than wider keys, and that helps us as well. Struck out multicast. People here don't like multicast. That's fine. Let's not talk about it. So, yes.
There's nothing in OpenFlow that actually lets you express that what you're doing as long as prefix match.
No, it isn't. It is implicit, right? Because you just arrange the priorities in order of the length of the prefix match.
Right. So it's implicit. And I'm wondering for both you and all the other vendors in the room, as much as I hate to break, I'm sure people are going to kill me. If we had a canonical way of expressing that intent, not that it would break the spec if you didn't follow the canonical way, would it help people if we had used the canonical way? We'll do a better job of inferring that this is really the longest prefix match table if their priorities start on a power 2 boundary and always, I don't know if that would help or not. It's not a hard thing.
More information, let's say, it cannot hurt, right? Because then after that, it becomes a software problem. If once the information is there, if we have the hardware resources that can take advantage of it, it becomes a software problem.
Whether you can infer, that's the longest prefix match table from the current stuff you're seeing, or whether you need more help to infer that.
We would probably need more help for that. I mean, right now, I look at it and say, this is a FIP table. I know it's longest prefix match. I can do fun stuff with it. But,
Until you get a flow that doesn't follow the pattern.
Then I'm in trouble, right? I mean, you decide that it would be nice to mask this IP addresses FF00, FF00. You could. Not sure why, but right.
The other comment I would just say is, I'm glad you have the functions listed in parentheses. Please remember, those may not be the functions we are implementing, even if those are the things we are matching.
Fair enough. No, that's what I said. I am talking of the major functions over here. So there are going to be plenty of other functions for which you need a lot of flexibility.
No. What I'm saying is that there are functions that have very specific and efficient use, but they aren't, and they're major for us.
Okay.
They aren't those ones.
Okay, fair enough. Point taken. Okay. And then yes, you'll always need flexible tables. Hopefully, they don't need to be very large. So there, you can put in L2, L3, L4 tables, whatever you want. We have single wide and double wide TCANs in our platform, which are 256 and 512 bits wide. So if they're only IPv4 fields, then 256 is good. 512 for IPv6. If you have a match which says, okay, on this VLAN, I'm interested in this TCP port, I don't know if it's V4, V6, and based on how I form the key, I may or may not need a double wide, especially if the IP field becomes optional. So I'm not too concerned about this because I think there probably won't be too many of them, and anyhow, I'm building a TCAM over there. So we definitely do want to leave flexibility at different points in the pipeline, but if we can constrain the flexibility, then life is good or better, right? So just what I've been talking about. So just how to be efficient. Choose your keys wisely, respectfully. Then better pipeline stages. Again, we've been talking about that. You have more logical tables with distinct functions, at least distinct matching. If you have mutually exclusive packet types, then you can have parallel tables, so you have some kind of a demux logic at the beginning of your stage. If possible, limit rewrite in the pipeline stages. I know we can't always do that, but that's something to look into. Groups came in more recently. Guess what? I like groups. They're good. You know, it's you have shared adjacencies. Your updates are more efficient, and you can do fun stuff with groups. So, for example, oh, this rewrite happens, and especially if you've already decided your forwarding action, you can postpone the rewrite to the end of the pipeline, and you can do complicated things. Especially, let's say you want to introduce tunnels later. I think there's creative ways in which you can use groups, and not just question of efficiency. Oh, this interface failed. Do I need to reprogram all the flows or just reprogram one group? Right. So that's a good thing. Okay. So conclusions, but this is not the end. I just want to start a conversation. Okay. So what are my intermediate conclusions? Building flexible pipelines is not necessarily easy. Fast, cheap, and flexible, as usual. You know, pick 2. Maybe we can get to 3 if we do things in slightly different ways. Maybe not a whole lot different. And you know, we have switch vendors, your application developers, end users, whatever. Let's talk and make the world a better place. Thank you. Yes, sir.
You seem to imply earlier on that it would be advantageous if once in one table you decided to package a certain type, with the next table it was easier to form hash key for it. So the example is like once you decided it's IPv6, if the next table is only doing IPv6 matches, this is better, right?
The decision of what the packet type is typically made in the parser, right? So we carry that decision through the pipeline. So if we can use that information, yes, we can do things.
So the actual question that's going to follow here is, OpenFlow mandates certain preconditions in the type matches.
Correct.
The
yes.
preconditions, of course, make perfect sense.
Yes.
But they remove the potential for efficiency and size of the hash key, because if you've already known because of the earlier states the packet is v6, then the fact that you have to go up and add an ether type field matching to your silly match seems annoying, and in fact, at least in one particular switch, caused us to blow out the size of their hash table. Like, oops, it doesn't fit anymore because we have this dang prerequisite match. My question is it reasonable to ask you folks to like say, can you infer that the prerequisite match is irrelevant, and therefore, even though I have to specify it, thank you, OpenFlow, you can like not bother to include that in the hash key?
Sure. It's not hard because again, that's software, right? So in the driver. So if you come and say, oh, this I'm going to match on IP. If I match on 0800, then I'm fine. It's just that if there is a possibility in that table that you might send me an ether type ABCD, then I still need to add those 16 bits. But as long as I know that I'm just going to match IP, I can just carry a single bit.
So now we just have to figure out and discuss how do we make sure that we know.
Correct. Yes.
So I'm loath to interrupt you because I fled this. So I just wanted to, I think we had one, Ian wants to give a lightning talk. Is that kind of correct? So,
okay.
I'm okay. Yep.
Are you sure?
Yep.
Okay. Does anyone else want to then steal his slots to do a lightning talk? Because I mean, if you...
I'm good. We can talk over lunch or anytime.
So I might then just declare morning tea then, I guess, and then we're going to come back and hear from Bill. Thank you very much.